Hello, friends. Welcome to Science Talk. I am your host, Jim Massa. I want to discuss with you some alarming research that's coming out of Greenland. Basically, I'm sure you're all aware of it. The Greenland ice is melting a lot faster than previously thought. It's really picking up in rate of melting. And now a new concern is that ice slabs can form that can hasten the melting, hasten the runoff, no, increase it, make it much worse. So let's describe this photograph here. We're looking at meltwater pools. That's these little things we see the cursor going. Those are meltwater pools forming on Greenland's surface. Temperatures rise and feed into the rivers, such as this, that funnel water towards the ocean. New research shows ice slabs are now forming in areas where water used to sink into the snow layer, increasing the runoff. So instead of the water sinking in there, you get a big flat thing and water just runs right off of that thing. So instead of the water percolating through and perhaps being retained and refrozen, whatever, nope, it's just running right off because you have these smooth, flat slabs. Towards the end of this presentation, I'll show you a little video animation that hopefully will explain what's going on here better than me blabbing away in words. So there's a new thing to add to ice sheet woes. Okay, just I talked about in the Antarctic situation, you have algae occurring in the snow and ice in Greenland as well, and increasing rainfall. I did a video segment some time ago about how there's winter rainfall instead of snowfall in Antarctica. Well, if it's coming down as rain, that means it's warmer than 0 C, which is going to do what? Help melt the ice. So you might want to check out that video. So these you have giant slabs of ice been thickening and spreading under the Greenland snow at an average rate of 2 football fields per minute since 2001. The slabs prevent surface meltwater from trickling down and being absorbed by the snow. Instead, more water pours off the surface of the ice sheet into the ocean, adding to the freshwater of the ocean, decreasing the salinity, decreasing the density, affecting AMOC. That's speeding Greenland's contribution to sea level rise, said University of Liège climate researcher Javier Fetweiss, who's a co-author of a study that was published in Nature. It's very likely that the current climate models overestimate the meltwater retention capacity. In other words, we're underestimating the meltwater addition to the ocean, and therefore underestimate the projected sea level rise coming from Greenland by a factor of 2 or 3. Not insignificant. Past summer was either Greenland's worst melt season on record or close to it, scientists said. Melting spiked in June, then in July, August, a heat wave led to melting over more than 60% of the ice sheet, including sending temperatures above freezing at the ice sheet's summit. All summer long, the average melt extent was much higher than the 81 to 2010 average. Now, I'll show some graphics with the data on that. There was also open sea ice north of Greenland at a record early date, and Arctic sea ice hovered near record low extent all summer. The formation, got the little not responding bit here. Okay, the formation of the ice slabs is connected to extreme melt seasons, like the one Greenland just experienced, said Mike McFerrin, the study's lead author and a University of Colorado climate researcher. Ice slabs are forming where they never used to exist because big melt summers are happening ever more frequently. 2019 is one of those years. If greenhouse gas emissions continue at a higher rate, fueling more warming, the expansion of the ice slabs could increase Greenland's surface runoff contribution to global sea level rise by half an inch to nearly 3 inches by 2100, McFerrin said. So let's look at this graphic here. Greenland's increasing meltwater runoff. Meltwater runoff has been increasing and occurring higher up the Greenland ice sheet during the warm season. So this is in gigatons per hydrologic year compared to the 81 to 2000 average. That's this horizontal line centered on 0. So the anomaly, gigatons per hydrological cycle, hydrological year. So if it's negative, okay, that means you formed more ice. And so we got more ice forming here, as we see, except for a couple of things here in the 50s, pretty much forming ice throughout the 60s, 70s, 80s, into the 90s. But then look what happens to get into the 2000s. Whammo. Except for this one little blip there. That was like the 1 year where the ice was observed. That's like 2018, where ice was observed to grow in certain spots of Greenland. But we can see the dramatic shift starting about the mid-90s, and basically been having more and more meltwater runoff. It is a feedback cycle, positive feedback loop, right? You've heard me discuss that to quite some extent. He does not say it's necessarily runaway feedback. Data would, yes, you got some high peaks there, but the data does support that contention. If you cool the atmosphere, the melting would slow down, as we saw in cases where the Arctic Oscillation, North Atlantic Oscillation would enter into more of a positive phase. But the Arctic keeps warming, so we see these slabs continually getting thicker and more extensive, reaching higher and higher portions of the ice sheet, moving further inland, further north, latitude-wise. We're already set to roughly double the size of the runoff zone by the end of the century, or more, or perhaps more if warming continues. And of course, coastal communities need to heed this. So Michael Mann, renowned, well-respected climatologist, there's no question now that we're seeing melts from both Greenland and West Antarctic that is far ahead of schedule relative to what most models previously predicted. Translation, it's going faster than we thought. Only a decade and a half ago, the IPCC was predicting a foot or so of sea level rise by the end of the century. Now we can no longer rule out 6 to 8 feet by the end of the century. Professor Mann tends to do underestimations. That's fine. It could be more. But the point is, it's 6 to 8 feet is definitely more than 1 foot. So the melt zone is expanding. So to understand how the ice slabs affecting the runoff, it's helpful to know that the Greenland ice sheet has 3 zones. Coastal melting zone. Snow that falls in winter melts away completely, exposing darker ice that melts quickly during warm summer weather. High on the ice sheet is the permanent dry snow and ice zone where there has been little melting, at least up to now. And in between, where the ice sheet begins moving upward, is the percolation zone, where surface meltwater trickles down into the zone and refreezes. What I said at the outset, if it's percolating down, it's going to refreeze as opposed to just running off into the ocean. This is the zone where McFerrin and other researchers first discovered growing ice slabs in 2012. And then they are using observations, modeling. They measured the growth of the ice slabs and where the ice sheet was stable. In 2002, they determined the slabs started growing fast. Some of the ice slabs have thickened from 5 to 7 meters in just 5 years and expanding inland. Thick layers prevented water from percolating down, and so the scientists found slush fields, runoff channels on the surface that sent torrents of water towards the ocean. Up until recently, nobody was paying attention to the cold, slow-moving ice in the interior, but now it's waking up, turning to warm, wet ice very quickly, which means it's well lubricated and it's going to start moving. These interior regions of Greenland didn't used to run off, so you didn't have to worry about them in terms of sea level rise. That's changing. The entire Arctic system, from its thawing permafrost to its diminished sea ice, is in a state of transition as global temperatures rise, said Mark Cerezi, who's director of the NSIDC, which is located in Boulder, Colorado. These ice slabs are not the sort of thing we were thinking about 20, 30 years ago. Basically, the ice slabs are making the runoff process more efficient. Every time we look, we see changes that suggest more rapid melting of the Greenland ice sheet than we thought 20 years ago. The kind of melting expected in 2050. The growing ice slabs contributed to what will likely be a record melt year on Greenland once the final data is compiled and analyzed, Fetwise said. In all, the ice sheet shed about 500 gigatons of ice in 2019, very close to the previous record of mass loss in 2012, mainly as a result of the surface melt that was twice the average. The extreme melting this year in 2012 is linked to changes in atmosphere above Greenland. During both summers, winds that usually transport weather systems from west to east stalled. I did a video talking about how the jet streams are changing because the temperature and pressure gradients are not as clearly defined as extreme. The jet streams are moving slower. And instead of staying in zonal flows, they're doing dips and doodles, becoming more meridional. So when they stall, they keep a big area of warm, sunny weather right over the ice sheet so the sun can just beat down on it. And with the basically 24 hours of daylight, you're going to see some melting. This year, one of those stalls happened in late June. Okay, this is 2019 now, to keep in mind. And this is from Ted Scambis, who is a polar ice expert with, again, the NSIDC. The second big melt event in July and August was when a European heat wave migrated over to Greenland. Obviously, since I'm recording this in July, mid-July, late July, so obviously August hasn't arrived yet, so this is obviously 2019. So let's look at this graphic, Greenland days of melting. So this is cumulative melt days. So if we look at the scale here, white is 0, and then it goes through blue, and then when you get to very dark brown or whatever, that's 100 plus days of melt days. What is a melt day? A melt day is when basically the ice sheet reached a melting point at least once. So if you have 90 days of melt days, that means 90 days temperatures on the ice was warm enough that it could start melting. So if you look at this, yeah, all this very bright white, 0 melt days. But we're starting to see the encroachment, right? Getting into 10, this is like 20, then getting into like 10. But we're seeing the encroachment approaching further inland. Along, near the coastal configuration, we can see 70, 80, 90, 100 or so. It makes sense right along the edge here. Okay? Sunlight energy along with the 3 zones that were mentioned earlier. So this is an interesting graphic because it's telling us that even this used to be all considered safe ice that wasn't going to melt. Now look at it. It's at least reaching the melting point at least 10 days. Hasn't quite gotten to this yet, but it probably will. Here is 20 days. Right? A lot of 20 days into 15 and 10, so on. So it's starting to affect the whole ice slab, the whole ice sheet. That's what that's telling us. So Fightwise said the extreme melting this year in 2012 represent what the IPCC projects for a normal summer in the 2050s. Sooner, if this continues, it's got here sooner than thought. If weather patterns over the Atlantic continue to stall, the tipping point, there we are again with tipping points, beyond which the Greenland ice sheet would continue disintegrating, could be reached twice as fast as estimated. It could even be reached at the end of this century if we do not drastically cut our carbon emissions. McFerrin said the implications of the rapid growth of the ice slabs are alarming. These features are going to play a bigger role as they get larger. The fact that these layers are very near the surface tells you this is recent in these areas. So, Basically, what it's telling us is that the ice sheet overall is starting to heat up. And then when you form the slabs, it's instead of keeping some of that melt water within the ice body itself, it's now running off into the ocean. Adding sea level rise, lowering the density, lowering the salinity, etc. So let me go over to here. This is so let me get that out of the way. Wobbly jet stream is sending the melting Arctic into uncharted territory. Here is the wobbling jet stream. Instead of being more this way, zoom like that, zonal, we see this dipping down. That's the meridional flow. Shift in weather patterns created a month of extreme melting, prompting scientists concerned about the impact on long-term climate models. So this extreme melting was linked to warm air delivered by the jet stream that is wandering. Basically, look at this portion right there. That brings in a high pressure system. No cloud cover, sun beats down. That's that branch right there. So extraordinary melting in Greenland's ice sheet last summer was linked to warm air delivered by the wandering jet stream. This is becoming more and more common. So in a paper that appeared in the journal Nature Communications, that basically described all that is happening here. So the study adds to an emerging theory on the effects of the pronounced warming of the Arctic, where temperatures are rising faster than in more temperate zones. And this is called Arctic amplification. This moderates the normal temperature incline that drives the jet stream. If it makes the jet stream wobble, it would suck warm air up into the Arctic, as was observed in Greenland. The new study analyzes the severe shift in wind patterns last July that transported huge masses of warm, moist air from the Atlantic to the Arctic, dramatically melting the northern reaches of the ice sheet. Never before has the jet stream been seen to intrude so far into the Arctic during the summer. That's this right here. Look how high up, right there. I mean, that's getting close to 75, 80 degrees north latitude. So basically, the obvious is going to present concerns about the ice sheet on Greenland. If it were to all disappear, it could raise global sea levels by as much as 20 feet. Michael Mann says 6 to 8 feet. Of course, it depends on how much melts. If only a certain amount melts, the 6 to 8 feet may be correct. If a lot more melts, then it obviously will be more. If all of it melts, then the same 20 feet. I'm not going to go through the rest of this. If you're interested you can go to insideclimatenews.org and search that website there for any such articles here. I do want to mention that one of the scientists featured in this report is Marco Tedesco, who is with the Lamont Doherty Earth Observatory, Wally Brown's old place. So, want to know, I'm not going to go through the article per se. If you want the information, go to nsidc.org/Greenland today, /Greenland today. Or just go to NSIDC for any information on ice anywhere. So, NSIDC, Inside Climate News, have you. But I'm just going to go through the graphics that we see here. Now, unfortunately, when I click on it, it doesn't really enlarge it too much. In fact, it actually makes it smaller. I hope you're able to see these. You might want to go full screen on your computer when you're looking at this portion of the video. What we're looking at here bottom panel shows the melt area day by day for 2019 in blue and several other high melt years. The purple is 20, it looks like 20, 2007, I think. Can't really tell. But 1981 to 2010, that's probably 2012. 1981 to 2010 is the median. That's this gray thing down here. And you see the error bars around it. So what we can see clearly is that in 2012, 2015, 2019 is more melting going on. That's what this is showing. 2012 was, you heard me mention that in the previously, that was one of the other big years of a large melting. And here's the spike here in 2019. So we're seeing some really big spikes in those 2 years. So that's a lot of melting. Here's a graphic showing the cumulative melt day area. This is 2012, the purple. Okay. The thick blue is 2019. The thin blue and lighter in color is 2018. That gray line there is the 81 to 2010 median. And then the green looks like 2017. What we're seeing here is that there was more melting going on in 2012. And we're seeing a similar trend for 2019. This graph shows the cumulative surface melting area. So go back to that previous diagram I showed where, the melt days, the number of days where the ice temperature reached melting temperatures. And this graph is tied into that. It's a cumulative melt day area. So in other words, what they're saying is that if you have an area that reached 10 melt days, you calculate that area. If you have another area that's bigger that reaches, say, 70 melt days, that's going to be a bigger area, so you would see that higher on the graph. So this is showing that in 2012 we had a lot more cumulative melt days. So it's taking that all together. It's showing air temperature difference and pretty warm from average. So this is really warm, and this is warm over the interior. So this is July 30th, August 5th, and then this is the sea level pressure. Very low sea level pressure. This is an interesting graphic that I wanted to show you. Snow and ice gain or losses to Greenland ice sheet. So the red is 2019, 2011 is blue, 2016 is purple, 2012 is green. And what this is showing is ice gain or loss relative to the average of 81 to 2010. So that's basically a 30-year average. And when you get into June, July, August, based on the height of summer, wham, it's just dropping way below average, meaning the melting has increased dramatically. This showing you again the ice melt off. The dashed lines are projected ones. Estimated melt runoff, total melt runoff, 81 to 2010 maximum. Okay, and then we have 81 to 2010 mean, that's this one here. And then we have 2019 in red. And you can see it's above the 30-year average. And then the melt in gigatons per day. This is the runoff in gigatons per day. So you can have melting. Let's just say, I melt 1,000 liters. Okay, I melted 1,000 liters, but say, 300 liters runs off. So the other 700 stayed on the ice. Okay, so you have 300 liters that ran off. So not surprising. This is kind of surprising. Well, if you look here at 2019, you can see that the spike is higher than, for the spike for the melt is higher than the spike for the runoff. Makes sense. You're probably going to experience more melt than having runoff. So these two graphs show the estimated melt runoff and then the total amount of melt in billions of tons per day for several recent years. Total melt amount over the ice sheet is higher than melt runoff because in many areas high up on the ice sheet, small amounts of melt seep into the snow and refreeze, leaving the mass of the ice sheet unchanged. And I mentioned that earlier in this presentation. That's what I wanted to show you from here. So now let's go and look at this animation.
We have a cutaway of the Greenland ice sheet. At the highest elevations, we have what we call the dry snow zone. Snow accumulates every winter there. In the summers, it doesn't really get warm enough to melt the snow. The snow just compacts down to what we call firn and eventually into glacial ice. This layer of firn can be anywhere from 100 to 300 feet thick. At the lowest elevations of the ice sheet, we have the ablation zone. Here, snow still accumulates in the winter, but in the summers, it gets warm enough to completely melt the snow away down to bare glacial ice. And all of this melt causes runoff. It feeds the rivers around Greenland every single year. We have a vast region in between these two that we call the percolation zone. And in these regions of the ice, snow still accumulates every single winter, but only partially melts in the summer. That melt percolates down and refreezes into this sponge of firn beneath, and it forms little ice layers. When we begin to increase melt in the summers, these layers grow more frequent, they intermix with each other. And if you keep this process up and add more and more meltwater, these layers merge together into very thick and continuous ice layers. When they get thick and continuous enough, you can cause a lid of ice over the sponge. The water begins to run off, just like it does in the ablation zone. And this causes ever-increasing areas of Greenland to run off and contribute directly to sea level rise.
Okay, so there you have it. Basically, what it's telling us is that more and more of the Greenland ice sheet is heating up. More and more of it is reaching melt temperatures. More because of the changing patterns of the melting and the temperature and the type of ice is formed. More and more melt water is running off and not staying in the system, which adds to sea level rise. In other words, Greenland is losing more and more ice and snow. So there you have it. More indications of all the changes that are happening to our climatary system. Thank you for your attention. Thank you for your time. Hey friends, this is Jim reminding you to subscribe and share my videos. Also, don't forget to click the bell so that you know when I drop a video in. And I'm also asking for you to please support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your continued support.